Hello everyone. Welcome to the EasyPower technical webinar series. My name is Jim Chastain. I'm your host for today's session. And we are fortunate to have with us Mr. Daniel Bruneau to share his experience with the scenario manager tools. And as we are in the habit of doing, before we get started, we'd like to run a couple poll questions, and we would appreciate your feedback. And there's no liability or obligation. It's strictly trying to understand the context of the use of the tools from the audience. So the first question is, when using Scenario Manager in your typical workflow, how many system configurations or scenarios do you use? If you would please indicate what your typical situation is. There's again no downside. It's strictly just to help Mr. Bruneau put some context in his material. We will be providing a certificate of attendance for everyone attending the webinar. You'll get those by email, so make sure that we have your correct email address when you registered. Okay, it looks like we have a quorum on this one. Let's see how folks have weighed in on this. Excellent. Super. And then the second question, which of the following have you used Scenario Manager for in the past? And this one's a little bit more. This is check all the ones that apply. To some extent, this list may change based upon what you get from the presentation. So please just kind of give us your understanding or use of the tool as of today. Excellent. All right, let me share these results. Looks like we have a quorum here. Fascinating. Well, it looks like we have the right audience today. And again, welcome everyone for attending. We've pre-recorded Daniel's presentation, and unfortunately we had technical difficulties with the video in the first 5 or 6 seconds, so don't be discouraged if there's a null point or there's a loss of audio, because it all comes back together and it's very much worth the wait. Daniel indicates that he'll take questions through the chat box. We prefer that you use a question entry form on the webinar control box. Again, thank you everyone for attending. Here's Mr. Daniel Bruneau.
Hi, my name is Daniel Bruneau. I am a product manager with EasyPower. And in today's webinar, I will be talking about how to optimize your analysis process with EasyPower Scenario Manager. Before I get into EasyPower and actually start the demo, I want to just go over a quick outline of what we'll be looking at today. Leveraging Scenario Manager, just a quick outline here. We'll be looking at, first of all, operating modes and switching conditions, source contribution variants, varying sources and scenarios, equipment parameter variants, looking at maintenance mode in scenarios, and then also recommended overcurrent protected device settings within scenarios. So just with that quick outline, I will jump over to EasyPower here. Bear with me for 1 second. Okay, so now that I'm in EasyPower, I have just a sample system here I've created for the purposes of our webinar. And as you can see, I've got a utility source here at the top. I've got a couple of distribution transformers that are feeding some low voltage switchboards here. You can see a generator that feeds an ATS and a small emergency system. And then down here, I just have a main system. We'll use that to demonstrate some more useful operating modes, etc. I've got some breakers up here, these mains that have maintenance settings. So we'll look at a variety of things here. So right off the bat here, what I'm going to do is I'm going to, and if you haven't seen or used Scenario Manager before, I see most of you have, you should get a pretty good feel for it just throughout the course of the webinar, but obviously any questions, etc., I can answer at the end here. So we'll create a new scenario, save that. And what we're going to assume here is the utility provided us a fault current. We're going to assume they provided this current as a high fault current. So we're going to store this scenario real quick just to give it a name. We're going to call this util for utility high. So it's going to be our utility high case. Now we're going to check a few things here. We're not going to change this fault current, because once again, that's our high fault current. What we're going to check first is to check that motor contribution is on. We want the most fault current possible in this scenario. So as you can see, globally, motor contribution is on. And then, as just a demonstration here, we are going to go to options. We're going to go to analysis options, short circuit options. So in scenarios, all settings, changes, etc. made within scenarios are unique to that scenario. So what we'll do here, since this is our high cases, we'll actually, just to demonstrate, we'll change this driving point voltage to 1.05. That'll give us a little more fault current in this scenario, and that will demonstrate settings being unique to scenarios. So we will OK that. And honestly, that's about it for this scenario. Pretty simple first scenario here, utility high. So we will go back and open the base case here. So yes, we'll store this scenario. So now, as you can see, we have utility high scenario. So now what we'd like to do is create a low case. We're going to assume either the utilities provided us a low fault current, or we're assuming something here, right? We're assuming a fault current. So I'll go ahead and create another new scenario. This one I will store as utility low, util low. Now, I'm going to edit this source, so some source contribution variance, right? This source, I'm going to say, let's say they provided us 6.25 kA and maybe 4K single line to ground current. Something simple here just for demonstration. So obviously this is lower. This gets highlighted to show that this equipment changed in this scenario. And we had motor contribution on for our high case, so we'd like to turn that off for our low case. So we're going to uncheck include motor contribution. That applies globally to all motors, so no need to go into each motor and set that and turn that motor off or deactivate it. That applies globally, and once again, that applies only to this scenario. And then just like we did in our utility high case, I'm going to go into the short circuit options once again, and I will set our driving point voltage, let's just say 0.95 here per unit. That is going to ensure minimum fault current, right, for this scenario. So we'll do that. And really that's about it. Pretty simple utility scenario here. So I will open the base case. We will go ahead and store that yes. And now with our two utility cases created, we can start to take a look at this generator, right? So we've got an ATS and normal operating condition here. Both of our scenarios had that in normal mode, obviously. So what we'll do is I'd like to create a scenario with this ATS actually in the emergency position, right? That different operating mode or switching condition. So once again, I'm going to create a new scenario. This one, I will go ahead and store it. I'm going to store this one as we're going to call this one Gen High. So what we'll do here is we'll come into the ATS, and we will switch this source connection. We'll switch this over to bus 2. So as you can see, once again, that gets highlighted in the scenario, signifying that that's been changed in this scenario. And now it's feeding from the emergency side. This generator is feeding our small emergency system here. So since this is our generator high case, I'm going to ensure, once again, motor contribution is on. Now, the reason I call this Gen High is I will also have a Gen Low case that we will see in just a minute. And one other thing to mention here, just to demonstrate varying some equipment parameters, is it's, potentially I may have assumed my subtransient reactance, these reactances, maybe they weren't provided, I didn't have a generator data sheet, etc. So I had to assume these. I assumed a value of 10 for my base case, but maybe I'd like to, in my generator high case, assume something less. Let's just say, and we'll just change the subtransient reactance here for demonstration. We'll change that to 8% here. So obviously less impedance there, higher fault current, and you'll see that gets highlighted, that color gets changed there to signify that there has been data change there. So once again, that's unique only to this scenario, both the ATS position and the generator motor contribution on. I think we are good with this as our generator high case. So I will go ahead and open the base case once again. And just one more thing to mention there actually is, in this scenario, I could go ahead and deactivate this utility source. That would allow, when I actually run arc flash or equipment duty, this scenario would give no results for any of this other equipment, obviously because there's no source there. But I don't have to do that. Effectively, what I have here is my utility high scenario, right, feeding all of these buses. So I'd get the same results, and in my comparison report, those would just get filtered out on worst case, right? They just get combined. So for what I'm doing here, I'll just leave that alone. but obviously if you want to be thorough and just make sure your scenarios look correct, you could just deactivate that source if you'd like. So go ahead and open the base case again. We'll store that. Now what we need to do now is generate a generator low case. So I could create a new scenario here from scratch, but actually what I'll do, and I think this is useful oftentimes, is I'll actually go ahead and I'll open the scenario I just closed. I'll open my generator high case. And so now I'm in generator high. And what I'm going to do here is I'm going to store this scenario, and I'm actually going to store it as gen low. So this is a new scenario with a new name. Now obviously all the same setup here. My ATS is still an emergency. My generator's been changed. I have motor contribution on. But what I'm going to do here is I'm going to go in and I'm going to actually edit this scenario and for what we need for the gen low case. So I'll increase this impedance, let's say 12%, just a higher value there. Obviously my ATS is good, and I will go ahead and I'll turn motor contribution off because in this demo we do have a 50 horsepower motor here. So we don't want that contributing in our low case. And so now I'm already done there. I didn't save too many steps here. Really, I just changed or saved the changing of the ATS. But in some cases, that is pretty useful. And I'll use that more as we move forward to just go ahead and open a case that's very similar to one that you're about to create, and then just go ahead and copy that over. I find that to be definitely a time saver and a little more efficient. So I think we're done there with our generator case. So I'll open the base case. I will store that, obviously. So now, real quick, just to review, we have 4 scenarios. We have 2 generator scenarios and 2 utility scenarios. So pretty good start there. And I think that covers a lot of our system. Now, what we have down here is a main tie main, right? So this tie is normally open. That's the way I have it set up in our base case. And I think it makes sense, right, to create a scenario, obviously, with that normal operating condition of tie open. We'll also look at creating maybe one case with the tie closed and one of the other mains open, so feeding from the A or the B side. So what I will do, and I really already have a scenario with the tie open, right? So let's go ahead and create that's my utility high case. Let's create a scenario. And we can, actually, let's create it from our utility high case. I think that would be easiest. So we'll go to util high. I'm going to store this scenario. And what I'll do is I'll call this util high, because that is the source I'm using. And we'll call this tie closed A. So we'll close the tie. Come down here to the breaker. We will, let's see here, we will close this tie. Okay. And we will open the B side. So that A I'm using in the naming is signifying that we're feeding all of this from the A side. So as you can see, right, these get the colors changed. We've had data change here, open and closed. Since I copied from utility high, obviously I have source contribution on. I'll just go ahead and show, if you take a look at my options, that I have my driving point voltage at 1.05, right, because I copied that over from my utility high scenario. That setting is unique to that scenario, so that looks all good here. So what I have is I now have a utility high case that is operating with this tie in the closed position, switchboard B's main open. So we're feeding all of this from just the switchboard A side. So that looks pretty good. So I will store that scenario. Yep. Now, I probably need a low case as well, right, for that operating mode. So once again, pretty easy here. I'm going to open. What I'm actually going to do, and I know I'm kind of jumping around here. Hopefully you're all keeping up okay, but I'm going to open my utility high tie closed case again. And what I'm going to do, I've got all this set up. I've got this all good. I'm going to turn off my motor contribution. I'm going to change my driving point voltage. All right, change that to 0.95. And I'm going to vary my source. I also could have opened my low case and done this, but I believe we had 6.25 and 4. And you can correct me if I'm wrong there. I believe that's what we had, but not too important for the demo here. But so I think we're good there. So now we have the base case. We have a scenario now for the tie closed feeding from the A side only for both utility high and utility low. So we can use that later when I actually demo running some arc flash cases. We can use that along with our other cases to look at all the operating modes here. And I could create a switch a side B case just to be thorough. I probably would in a normal study, but for the purpose of time, we'll just assume that we did that. We'll roll with our just our utility highs on this. So that's a pretty good view on this system, I think, of changing our operating mode, some different switching conditions, some different utility contributions, generators, varying settings in our generator, vary those equipment parameters. We varied, obviously, our utility source. We varied some settings or some short circuit settings within those scenarios. So we have all of that set up now. So before I jump into actually running anything with Scenario Manager, what I would like to do is create some cases for maintenance settings. So if I take a look at these two breakers here, both switchgear 1 and switchgear 2 main, these are square D masterpack NW breakers, and I have maintenance modes on these. So presumably I might like to generate an arc flash table perhaps for a customer with separate results with maintenance settings on, right? This breaker here I actually have set up, I'll show you here, I have it set up to trip for this bus here, assuming that breaker is isolated, so it's got including mains. This breaker will actually trip for arc flash. Both of these will. So I'd like to set up a couple scenarios for maintenance settings. So what I will do is let's just start with utility high. We'll build from there. So we'll open our utility high case. I'm going to go ahead and store that. I'm going to store that as utility high. Let's just call it utility high with maintenance settings, right? So now we have our utility high. Everything from utility highs is still applicable here. And what we're going to do is I'm just going to come in here to these breakers. And you can make any settings changes. We'll see that here in just a minute when I make some recommended settings changes and TCCs. But for this case, I'm going to turn maintenance on. And we'll just go ahead and set it to minimum here. Maintenance on. You can see that gets highlighted. I'll come in here. Sorry, and I'll turn maintenance on. Minimum highlighted. So perfect. I've got both those breakers set to the maintenance settings. That is only applicable within my utility high maintenance scenario. None of my other scenarios are affected by that. You wouldn't want to set that maintenance mode on in the base case because that would then propagate through to any scenario you opened. So we're good here. We've got this utility high maintenance case set up. And what I will do is I'll open my base case again. Let's set up, while we're at it, right, we might as well set up a low case for maintenance. We could also set up our tie close cases as well. I won't go through all of that. That'll just take more time here, but let's go ahead and set up a low case. So we're going to do the same thing. We are going to store this as utility low maintenance. We're going to come in here. We have all of our settings from our low case in here now. We're going to go ahead and come to this breaker, turn maintenance on like we just did. Yep. Turn maintenance on like we just did. Once again, that's only applicable to this scenario now. I'll open my base case. That's all good. All right, perfect. So now let's take a look at where we're at. We have two generator scenarios, a utility high and a utility low, normal operating conditions. We have a utility high with the tie closed, feeding just from, on that main tie main there, feeding just from the A side. And we have a utility high and a utility low with maintenance settings applicable, applied to both switchgear 1 and switchgear 2 main. So pretty good. We could easily run, and we will here in just a minute, we can easily run cases for just the maintenance together. I'll show you how to do that in some configurations here, and we could run our 5 or so cases that we have for just normal settings with utility high, generator, tie close, etc. So before we do that though, I did want to demonstrate making some recommended settings changes. So it's going to be similar to the maintenance settings changes we made, right? So what we'll do, let's take utility high. Let's take utility high and let's store this as utility high recommended settings, right? So this is our utility high contribution, all that set up, but now we're going to make some recommended settings. So I already made a TCC for this, which is called TCC1. Yes, that's fine. So you'll see that this TCC has some miscoordination here, right? Fairly minor here, some miscoordination here. This could probably be improved a little bit, right? Maybe we found these settings were as found, existing facility, whatever it might be, recommended settings need to be made. So we could make changes here, but what we're going to do actually is we're going to create a new TCC within this scenario. So if I remember here, let me make sure I grab the right breakers. That's fine. So this is, yep, so it's switchgear 2 to panel 3. So I'm going to grab all that, including the main. I'm going to grab all the way down to panel 3. I'm going to plot a TCC. And you'll see this is called TCC1. That's just the default name. I'm actually going to store it as TCC1 as well. I've already got my other TCC named TCC1. You can see here this tilde that gets put in here. That is generated for any TCC generated in a scenario. That lets you have the same name. It just signifies that is a TCC made in a scenario. So I will go ahead and store that as such. And now what I'm going to do here before I organize all this, I won't do too much of that since we're sake of time, delete a few things here just to clean it up. Let's just say simply we'd like to take this breaker here. This is the breaker, the feeder to panel 3. Obviously, we would like that to coordinate with the downstream panel, the breaker in panel 3. So let's just simply make that settings change. I believe these are LI breakers, so not too much we need to worry about right here. Make sure that we're clearing inrush with the upstream feeder, which I believe we are, yes. So that's, I think, good enough for our purposes here. We will store that TCC. Another thing you might add here, just in the comment, would be, this is recommended settings. You could even add it to the name potentially if you'd like, right? You could store this, and I'll just show, you could store it as, TCC1 recommended, right? Just so that's in the name. So now we'll have 2 of those TCCs, but that's fine. So we have both of those TCCs now. We have a TCC in our base case, that's just our normal as found settings, and we have a TCC here in our recommended settings case that has recommended settings. Obviously, within our scenario, we have those recommended settings applied to just this breaker here. Obviously, you can apply that to as many breakers as you might need to. So I'll close that TCC. So a few things to note here. One, we now have a utility high scenario, and we can create scenarios for really all of our operating conditions with these recommended settings, or whatever ones that we would need to with the recommended settings. So we can do arc flash for just our recommended settings, and I'll show us how to do that in a minute. We can generate TCCs for just recommended settings. And I can print a TCC directly from here, right? I can print my recommended TCCs, as you can see. I can also output settings for my recommended breaker. Say I know that just this breaker has recommended setting. I could obviously export settings for all my breakers, but for, so let's say just switchboard 1 main, I could come here and I could create a coordination report for just this breaker that I know has the recommended settings in it. Various ways you could go about all of that, right? But this, having these in a scenario lets you leverage anything you would want there to be able to output results and run arc flash cases for recommended settings. A pretty powerful thing here, both for maintenance, recommended settings. Really, once again, any equipment changes you would need to make are stored directly in this scenario. So this change we made to this breaker is applicable only to this scenario. Any changes we make in the base case to that breaker will not overwrite the changes we made here. So I believe the only change we made here was to raise, or I'm sorry, it was on the feeder, wasn't it? Yep, sorry. Was to raise the instantaneous from, I believe it was on minimum, to 5, right? So any change I make in the base case, I could set that instantaneous to 7 or 3 or whatever it might be, and that will not overwrite the changes made in this scenario. So just to be clear, obviously any changes I make here would to any of the other settings, but it won't get overwrite any settings that are actually changes that are actually made here. Okay, with all that being said, let's jump back to database edit here, and we will jump back to the base case. And real quick here, I think it would be useful to, actually I just closed that scenario, but let's open this. Let's open this back up. Let's store it real quick as utility low. Just so we have two configurations for these recommended settings. So my recommended settings will still be applicable, obviously, because I just moved that case, saved that case as a different. You'll see same instantaneous, right? I'll go ahead and just change this real quick since I'm here. 6.25 and 4, and I'll change real fast our analysis options, short circuit. Set this to 0.95. You saw that was obviously 1.05, so I'd copied it from the utility high recommended settings. And I will turn off my motor contribution, just so we're clear on all of that. Okay, so this scenario is good. We've got two scenarios there. Let's open our base case again. Okay, now we have quite a few scenarios. We've seen quite a few different things here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so with these scenarios, let's actually get into Scenario Manager and let's look at creating a scenario comparison report. We'll just use ArcFlash for this example. Obviously, Equipment Duty can be used as well. Let's use ArcFlash. So what I've done is I have a custom view created, just to show real quick. This custom view has some selected columns from our ArcFlash report. I have a custom equipment group as well. So to show that, I selected just the equipment that I wanted ArcFlash results for. I didn't include any of these. These are just node buses on transformers that I didn't name. So I've got that. And then all I have right now is all scenarios. So let's create a couple scenario groups here. So let's add one. Let's just call this one, normal or base, something like that, right? So what I'm going to include here is I'd like comparison for my generator cases, my utility high cases, utility low, and the tie close case I made. Obviously have some more cases normally to be completely thorough there, but that's pretty good. So I'll leave out my recommended settings changes here. All right, let's create one more, pretty easy here. We'll call this one maintenance. And we could populate this with all the maintenance cases we may have made. In our case, we only made 2, that's fine. And then let's add one more finally. We'll call this recommended settings. So we'll add our 2 recommended settings cases we made in our case. Save that. So from this drop down, I can do a few things. I could run all my scenarios. I don't think that makes sense in our case. That's not really what we want to compare, right? We want to compare our normal settings, our normal cases to each other. We want to compare the maintenance cases to each other maybe, and we want to compare the recommended settings cases to each other. So real quick, I'll just run, let's actually run our normal case. So let that run. What we'll see here is that, for example, for ATS1, we've got all of our scenarios here. We've got results for all of those. We can select just worst case results. We can see those. Maybe here, just for example, let's note on switchgear 1, the actual load side of that bus. We have an incident energy of 2.7. It's probably, maintenance settings might change that. I think those were already set pretty low just because I didn't really set them. 2.7, 5.4. Let's see if our maintenance scenario is any lower than that, just because we have those set on very much minimums. So all I'll have to do is come back in here. I'll run my maintenance. Same group of equipment, same view. Those don't really change once you set them up the first time. And let's see real quick. So switchgear 1. Switchgear 1 still 2.7, so no reduction there. But you can see switchgear 2 changed, right? So 1.9, that tripped faster, and we ended up with a lower incident energy value. So, you know, in a normal scenario, you'd probably have those breakers set higher than that. Maybe your incident energy is, you know, much higher than it is here. You might see a pretty big reduction in incident energy. You can provide a table to customer for, you know, separate incident energy values, separate ArcFlash values for maintenance mode settings on, and potentially maybe even label for those. Just depends on your processes and standards. Let's see here. So that's a pretty good coverage now, I think, of everything in the system, the different source contributions, setting up different operating modes for ATS, for our main time mains, different settings. We have maintenance settings, we have recommended settings, we varied equipment parameters, we varied some actual analysis settings within these scenarios. I've got a few minutes here still, and what I'd like to do real quick is demonstrate that we can actually add equipment within a scenario. So I could add extra equipment in a scenario. So let's say I've got some loads down here in these panels. Let's say you're looking at adding load to a facility, just a simple example here. This could also be used for alternative designs. Maybe you have a system that has some design, but there's an alternate being proposed, and you could run analysis on both. You could have separate scenarios for those, etc. So real quick though, let's just create a scenario. And this can just be, I'm actually going to show power flow here, so it doesn't really matter here. I tell you what, we'll just create it from scratch. We'll store it as alternate, or let's say facility load edition, right? I don't know. Okay. So say we have I'm just going to go ahead and copy and paste this load. Let's say we have a 50 kW, 50 kVAR load, just for example, that we'd like to add somewhere in our system. We'd like to add it really anywhere down here. Any of these panels could work, for example. So what we can do, and this is specific to this scenario, so I added this load, load 1 in this scenario. This load is not in the base case, it's only present here. So I added it just to panel 1 here. So let's see if we just jump over to power flow real quick, and we solve the power flow. If we get any issues. So yeah, it looks like makes sense here. We've got some line overloads here on this cable. We've got over 400 amps on a cable rated for 290 amps. We added a decent amount of load to a panel that was already reasonably loaded. So we can go, hey, man, that's probably not the best idea to stick that there. Let's disconnect that and let's put it over. Let's just put it over here, for example, where we've only got 10 kW of load, and we've got a 400 amp breaker here, and only a 1/0 cable. Let's change that actually to. Let's just change that real quick to. Let's just change it to 2 sets of 250. Plenty size there. Once again, that settings change would only be in that scenario here. I made a mistake and didn't have that cable appropriately sized, but that shows you here once again that varying that parameter in this scenario is only applicable here. So maybe we were upsizing this feeder to add some load. But let's see what happens now. We have this added here. You can see it's colored. It's an addition to the model. Let's go to power flow. Let's solve it. So we've got some voltage drop issues, but we could play with this. This is an actual facility that had been appropriately designed and not put together for a webinar. It probably would have been a little closer there, but it looks like we're just over the amount of voltage drop we have set for our thresholds there, 5%, I believe. But anyway, as you can see, right, we can add that load, we can play around with where it might go, we can play around with alternative designs within these scenarios, we can add equipment, we can delete equipment, move things around, really anything is possible, and you can do basically anything you would need to. Leveraging scenarios for that is very powerful, instead of trying to always make changes maybe to a base case or have separate models, whatever it might be. Being able to utilize scenarios is definitely a powerful thing, and something that, at least in my past experience doing power system studies, was something that I used in certain ways, but I definitely didn't utilize all of the options and abilities of Scenario Manager. So hopefully that showed you all some new things, maybe some things you hadn't thought of before, some workflows, some possibilities that you could use moving forward. That's all I have. That's all I have planned out here. If there's any questions or comments, check the chat, and anything you'd like to ask now, I'd be happy to answer. I appreciate your all's time for sure.
So the video is ended, and we've got a couple questions. Daniel, you want to unmute your mic?
Yeah, for sure. You guys hear me okay?
Yeah, so one of the questions that's come in that may have been when you were offline, Diana is asking, are all changes in the base case propagated to the scenarios? For instance, the removal or addition of a breaker or an entire branch?
Sure. So, okay, so any changes to the base case? Yes. So the easiest way to think about how this works and how it works, in fact, is your base case obviously is just that, your base case. When you create a scenario, effectively what EasyPower is doing is it's recording those changes that you're making in said scenario. So maybe I change the utility contribution, I might add a piece of equipment, I might delete equipment, et cetera, within said scenario. That's all recorded. And then saved. And so when I open that scenario again, it's effectively just playing those changes back onto the base case, right? So if you remove or add breakers or an entire branch within your base case, that will be reflected in the scenario because you're trying to make go through those macro changes to that scenario. So for example, if you changed a utility source value or even just had it in general, a utility, let's say, and you deleted it and went into that same scenario that you created before, you would get just an error message saying like, hey, this no longer exists in this scenario. So what you would get is that scenario with whatever equipment you deleted gone. Basically, any changes you've made to said equipment in the scenario obviously would no longer be applicable. So not really an issue if you know what you're doing and you know how to handle that. But obviously, you do need to be careful that if you delete equipment in a base case, that's no longer going to be within that scenario. So if you're going to delete equipment, maybe for some kind of alternate something, and you'd like this to see results for that, probably makes sense to delete that in a scenario, not within the base case, unless you're just removing it from the system in general. In that case, that's obviously fine. Hopefully, that answers that pretty thoroughly.
That was a pretty good job. The point that struck me, and Diana, her question, I think, doesn't emphasize it, and that is when you change the settings in the base case, it doesn't override the scenario.
Correct. Yeah, so like I was saying, if I change that instantaneous setting or really anything, I might change breaker settings or analysis options, all those things. That's not overriding anything in the base case. Any of those changes are being made in a scenario or are being recorded and played back and put on top of the base case. So yeah, it's no worries in overriding things in scenarios that you've made changes to.
So I wanted to apologize to the audience for our technical difficulties. We'll try to deal with those in the future. I don't see any other questions come in. Let's give it a couple minutes. Diana.
I think there was one.
Yeah.
There was one more maybe. What happens to a scenario if the base case is reconfigured or equipment is renamed? I think my previous answer is still applicable here, right? So if you are reconfiguring the base case or if equipment is being renamed, that may or may not cause issues depending on what you're doing within the scenario. Like I said, the changes in the scenario being recorded and then played back onto the base case to reopen that scenario. So it just depends on what you're doing. Renaming equipment, et cetera, is no problem. Those equipment names will just show up in the scenario as changed. Reconfiguring also isn't an issue. You could move a feeder somewhere else and open a scenario, and that feeder would then be moved somewhere else in the system. Any changes you made to the breakers or any of the equipment in said feeder would still be made. That feeder would just be connected elsewhere, right? Oh, I'm sorry, Diana, you had a follow-up there as well. Delete the equipment in the scenario. If you can delete equipment in a scenario, that shouldn't give you an error unless maybe you've made changes to that. I'd have to check on that. That might flag it as, hey, this no longer exists in the scenario. I can't make that change. If you made a change to a breaker or a utility or something, and then you deleted it from that scenario, I'd have to check on that. That might give you throw you a warning. But you can dismiss those warnings as needed. I do believe they will continue to show up once they do, because they're flagging it every time they come in. I'd also have to check that though. They might be able to dismiss those. Can't remember on that. No issues though, just warnings saying that, you know, couldn't make a change to this equipment, or this equipment doesn't exist anymore, etc.
Any other questions? Well, thank everyone for attending today. Daniel, thank you for the presentation.
Of course, yep.
And we'll work on our technical difficulties for future improvement. Thank you all.
Thank you all. Appreciate it.
Have a good day.